Hi everyone, this is Mike North, and today I'm going to be talking to you about building great user experiences for distributed systems. First, a little about me. I am not a distributed system expert, and I consider myself to be a product guy who codes. I tend to be attracted to opinionated web frameworks because, in my mind, developer productivity is at least as important as some of the highly focused on technical factors. One of my passions is helping developers and teams be as successful as possible with my favorite technologies. I do workshops and trainings all over the world and will probably be coming soon to a conference near you. Check out my website for more details if you'd like to learn about how to get the most out of tools like Elm, Angular 2, React and React Native, and Ember.js. Today I'm going to talk a little bit about things I've been working on as the CTO of Levanto Financial. We're going to dive into some of the work that we've been doing in building our next generation product, talk about how it's changed my perspective on UX-driven design, the ramifications on app architecture that the UX-driven design has led us to, and hopefully the takeaway you'll get is that Beam technologies and the real-time systems we can build on top of the Erlang virtual machine are a fantastic foundation for the products of tomorrow. A little context about the problem that Levanto is trying to solve is that, particularly in America, people have a lot of trouble reaching their long-term financial goals, even in cases where they bring home a lot of money on an annual basis. So this is an article from this May's Atlantic magazine that dives into this issue and in particular focuses on the fact that people don't like to talk about money, and it's likely that people in your life are having a struggle that they could use some help with. So some of the high-level takeaways from this article were that 48% of households in the USA would struggle if they were hit with a $400 unexpected problem. And even if we just look at those households that make over $250,000 a year, 35% of them wouldn't be able to pay the deductible on their car insurance if they got into an accident tomorrow. Despite the fact that many budgeting solutions exist in the market, technology falls short of saving this problem. By the time people make it to Levanto, they've tried 4.7 different apps. They have a very complex financial situation and are often carrying carrying a balance on one or more credit cards. But in spite of this, they still have a very high household annual income compared to the national average. So this is someone that is not incredibly difficult to help because the cash flow is high enough that we can start to make a dent in that personal consumer debt. So we believe that the reason that technology falls short is that they're missing an important piece of the puzzle, and that is the involvement of a human expert. Sometimes we aim to avoid involving people in workflows, and particularly lately, where there's a big craze around artificial intelligence, startups, and chatbots. In this case, there's clear evidence that the automated solutions aren't working. And I believe that what we're seeing here, the idea of applying automation to human intelligence, is something that is going to take hold in the service economy on a very large scale within the next couple of years. You'll start to see a lot of conversational UIs built around chat, where you start out talking to a chatbot and then are funneled into the appropriate customer service area where you can start talking with a human being right through the app. When I was working on this talk, I toyed with a couple titles. This is the first one. Not really appropriate, but still a valuable point. When we're working on our dev environments, we don't really get to experience the full scale of our system, and there are bugs that can really be detrimental to the user experience that won't really pop up in your dev environment. Here's another one. I know it's tempting oftentimes to see that there's great technology on the horizon that promises to be a drop-in solution for some of the problems that we have today, like building progressive web apps that seamlessly sync up with your backend as they go offline and come online again. Today's talk is a call to act now to build great UX today, even if the perfect solution is not quite available yet. And in case there is any doubt, everything that we do, it doesn't matter if you're working on, database architecture or building, back-end distributed services or working in the web UI or building mobile apps, everything we do impacts the user experience in non-trivial and important ways. And I hope today we'll start to form a framework of thinking about these problems that transcends a particular section or a particular system component in terms of how apps are traditionally structured. So in the case of Levanto, despite the fact that we have unreliable third-party services to couple to, trust is absolutely key, and we cannot make our downtime the union of the downtime of everything we depend on. Despite the fact that we have manual, human-powered slow processes, oftentimes on the critical path for workflows, our users demand a modern and engaging experience. Despite the fact that sometimes our data is a little bit out of date or approximate, we still have to have clear and actionable insights and takeaways. And in order to solve these problems and in order to find the balance between all of these factors, we need to make sure that we think of things in terms of distributed systems, especially when you deal with reliability issues, connectivity problems, collaboration tools involving multiple users sharing state. You really have to come back to this mental model, because the idea of, single browser talking to single API, that just doesn't hold up. Particularly when dealing with financial technology, a lot of people in the space are operating on antiquated platforms. We see a lot of online banking portals that don't yet support Google Chrome and prompt users to go and download the latest version of Microsoft Internet Explorer. Microsoft doesn't even like to call it Internet Explorer anymore. So this is not just a great foundation for us to build on, but potentially an opportunity to, help pull this whole vertical along and set a good example for what's possible in a secure and sustainable way that works for fintech as a whole. For a back-end choice, we needed something that was highly fault-tolerant, that was a great foundation for collaboration features and for chat, and could deal with a lot of background concurrency gracefully. So Elixir was a logical choice. It was a bit of a risk when we started building on it in mid-2015, but it's proven to be a delight to work with, and it gives us a great foundation that is based on Erlang and the Erlang virtual machine, while providing some modern language features like pattern matching that just make it a joy to program with. So, and if you're an Erlang developer, this may be a little bit more relatable for you. So this is what our complete stack looks like. We use Phoenix framework, which is built with Elixir and is akin to, the Rails of the Elixir world, although it's different from Rails in some important ways. On the front end, we have a modern server-side rendered single-page app built on the Ember.js framework. Our mobile app is built using Swift, and as a database solution, we use Postgres 9.5, which has been wonderful and quite performant for us. So the first area of our app and the first flow I'd like us to examine is what users go through when they need to connect a bank account to our system. The screen they're faced with looks like this. And this is, for most people, the most painful part of the off-the-shelf stuff that we usually compete with, or that we, usually are the next generation version of. And this would include things like You Need a Budget and Mint.com, And any of these things require that you connect your bank account. The distributed system UX challenge that this falls into, the overarching category, is long-running stuff that you can't really do too much about, right? There's a bare minimum here that lies outside of our system that takes time. And so we have to build a good user flow that in a distributed system way that makes this as painless as possible. And first, I'd like us to examine our starting point. So this is sort of the classic solution. The idea is the user types their information in, they click a button that says link my account, and then ideally we talk to a bank through an API, but more often than not, banks don't have APIs. And so we, through a third party, use a screen scraping service, which essentially is a farm of, browsers that, you fire up a new secure browser and you programmatically log into that bank account. And, you're downloading all of the images and other static assets as you go along. And it takes quite a while, oftentimes many minutes. But eventually the screen scraping finishes and we can return this object that is basically a linked bank account. So we get a token and we can store that account information in our database in a secure way. At this point, the user can leave the system because we know everything has worked successfully. And this works. It has worked, right, for prior solutions, but it is incredibly slow. And we found that people were oftentimes not entering all of their information because of the amount of pain there was in, hooking up all of those 14 different accounts. So we'd see a partial view of their financial situation instead of the whole thing. And when we see a partial view, we can't really help them as much as we otherwise could. The total time it took for people to onboard this average number of 14 accounts was about 1.25 hours. This is obviously not ideal. In fact, I would say it's not even acceptable, but it is the situation you're in when you connect these bank accounts in serial and don't have any clever asynchrony going on to respect the user's time a little bit more. As to why this takes so long, it's no mystery. It's 6 to 15 minutes per account. So that's one standard deviation away from average. That means 95% of our connection times fall between 6 and 15 minutes. And this isn't even the reality of this usual scenario. More often than not, after we begin screen scraping, the bank that we're connecting to detects that this is an unfamiliar IP address that this account is being accessed from. And so it will ask that the user enter a special authorization code, which they usually send to the user's phone on their, via a text message. And so we have to then go and ask the user for that information. They'll type it in. That response will be passed back through our API, and then we can resume the scraping operation. I'm going to refer back to a diagram that looks like this at several steps during this section of the talk as a way of showing what work is being done in parallel. But you can see at our starting point here, everything's done in serial. We have to wait for a bank account connection to complete before we start the next one. There's a small improvement we can make that will dramatically reduce this time down from 75 minutes. And that has to do with the idea of allowing the UI to go about its business while the API continues to work with the banks, during this asynchronous background process. So we return this idea of a pending account to the UI, and then if at some point down the road the bank requires this authentication code, we can pass this up to the user who will still be, at the web client, and ask them to enter their, security code. They'll enter it, and then we'll pass this response back through, and then we can finish the screen scraping. The way we do this is we have some tooling around global notifications. So no matter where the user has moved within our web app, if through a WebSocket we get information that, a pending account needs the user to be involved, we can bring them back in. In terms of the effect this has on the total time it takes to connect those accounts, we reduce it from 1.25 hours down to 15 minutes, a massive improvement. And as for our waterfall diagram here, you see that we can start everything one after another, and we only have to wait for the longest connection to complete. So this is much better than what we started with, but we can improve on that even more. And this is important because the 5% of accounts that fall outside of that single standard deviation sometimes take an extremely long amount of time, sometimes longer than an hour, sometimes longer than a day. And so we need a solution that is tolerant of that, or else we end up having an incredibly poor user experience for a non-trivial number of users. So in terms of the sticking point of why we have to keep the user at the console here at the website is because we need them to enter this security code right at this moment in the timeline. This is what's pinning us into our current situation. And if we found a way around it, we'd be able to allow the user to walk away, and bring them back in when needed. And this brings me to the topic of interruptible user flows and bringing the user back in when you need them. So an obvious way of handling this is with messaging and push notifications, but it has to be handled gracefully because particularly when they're setting up a whole bunch of background processes at the outset of a relationship with us, when they're first hearing about the company, they're first testing out an app, you don't want to have 20 or 30 notifications there, and all of the text messages will be coming in at the same time. It's very easy for wires to get crossed and for the experience to be incredibly negative. So to mitigate this, we have built a notification delivery pipeline. And the idea here is that we first try an in-app notification, and if we see no indication that the user has responded within a certain period of time, currently 3 minutes, we fall back to a push notification to the mobile app. If we don't see any response to that push notification, our last resort is to send them an email. Now we need mechanisms in order to tell whether the notification has rendered and whether it's been interacted with. So in the browser, we use Phoenix Presence and browser events to make sure that the WebSocket connection is active, and ideally that it's been clicked and that the user's at least at that screen, waiting to type the number in. In our mobile app, we use blocking modals, so the push notification is associated with a deep link, which will take the user to our app, and then they really can't do much in the app until they enter the security code. And this is because it's really important that we get them set up initially and that they're encouraged to add as many of their bank accounts to our system as possible so we can get a complete picture of their financial situation. Finally, for email, we just use a pixel in the body of the email so we can tell when it's actually opened, and that will be the moment at which that pixel is requested. So in terms of how this affects our timeline here, we're no longer required to stick around and wait for the longest leg to complete. In fact, we don't even have to wait for the first leg to complete. And so now what we've done through making a profound improvement here is that the time it takes to onboard is not a function of which things you're trying to connect to. It is basically a function of how many accounts you have and how long it takes you to enter that data. Our worst case is now dramatically better than it was before, and our upper bound in terms of the most complex financial situation we can handle is much higher. So we have some people that have 30 accounts, and this would have been unthinkable before, and now is only twice as hard as someone with half as many accounts. It is pretty linear, which is fantastic. So this is the sweet spot, and the way we know it's the sweet spot is that the the pain or the work required is tied to the number of tasks that a user must complete, and we've removed some of this uncertainty and randomness from what the user can expect in terms of a weight. So one of the other challenges we dealt with was how do we make a traditionally structured client-server app feel like a real-time app? And this is part of the foundation of how we deal with connecting to bank accounts, right? So we were able to get away with a very small change that had massive ramifications on the way our app feels. It feels like a completely real-time app, despite the fact that we were able to just start with a traditional REST API, surface, and add 4 types of WebSocket messages. And those 4 types do enough that our app seems as if we're passing data continuously through WebSockets, and it's totally in sync with only about a half-second latency between server and client, in addition to network latency. So the first type of message is a server-side originated notification, and that shows up as an in-app notification message. The second type of signal we push from server to client is an instruction to invalidate a record from the client-side cache and to potentially refetch that record. But that decision is left to the client because we only want to refetch it if that record is needed for the current screen that the user is on. And so this allows us to keep our browser sessions completely in sync with server-side data, even if it's shared between people like multiple family members, managing the same reports and editing the same transaction categories. All of that is in sync. The third type of data we push from server to client is a request to gather information via a structured form. And this is important in terms of getting those authorization codes. They differ from bank to bank. Sometimes it's an image and they want the user to identify that image as being correct. Or sometimes it's the last 4 of their social and the code that they were sent via text message. And so we need a flexible way to describe the structure of a form and then to basically ask the UI to respond with data that filled that form in. The final payload that we send from server to client is clear, and that basically instructs the session to evict the local storage, to remove any client-side cookies, and to reboot the UI session itself to evict JavaScript memory. And this is a nice security measure to have in place, particularly if we see an unauthorized session. We have the ability to remotely, terminate that, and even if there's some attack that's ongoing, like if there's someone steals a customer's password, we have the ability to kind of force a log out everywhere, instantaneously, and then, require a new password from that point on. The next topic I'd like to talk about is dependencies on unreliable systems. And here's the main problem that we have to deal with at Levanto. This connection to banks, particularly the banks that we have to resort to screen scraping with, it is quite unstable. When the banks change the way their online banking portal looks and change the DOM structure, the scraping algorithms that we depend on will often break, sometimes for days at a time. And we need to make sure that our app doesn't go down every time this happens. A good problem-solving technique for this kind of thing is to first outline your critical dependencies and then to come up with ways that you might be able to deal with getting around, this hard dependency. Little plugs you can put in to fill the gaps. So the first thing we need from banks is the ability to connect to new bank accounts or other sites like bill pay sites and insurance sites. We also need the ability to repair broken connections. Occasionally, the banks invalidate the tokens that we get. They give us this, offline access to the bank, and the user will have to re-enter their credentials in order to reestablish the connection. The third thing we need is the ability to pull new transaction data, and this we do very often on 2-minute intervals. And this is how we stay up to date as new, credit card and checking transactions come in. So let's think about what we can do in terms of mitigating a hard dependency on, these things being available all the time. To handle the ability to receive requests to connect to new accounts at any time, what we've put in place is an AES encrypted message queue, where essentially we can allow, even if this connection to the banks is offline, we can allow data to securely, pile up in an organized way. And then when that connection is reestablished, we can sort of flush it through and continue about as normal. The way we've been able to do this without requiring PCI compliance is we use a public key that's provided by our third-party partner that gives us access to this banking information. So we only have the ability to encrypt. Our system doesn't even have the ability to decrypt again. So once we, create this encrypted payload and push it into the message queue, we've basically lost access to that username and password in any meaningful way. And our responsibility is, to just make sure that is removed from memory. And with Elixir, that's going to happen basically as soon as that initial background job is finished. It'll be immediately garbage collected. We handle repairing broken connections in the same way. We have a separate AES encrypted queue, and essentially the credentials wait in this queue in a form that we can't even access. And when that connection is reestablished, we will retry until it's successful, and then that will get removed from the queue, and the workflow will continue as described earlier in the talk. In terms of the ability to pull new transaction data, this we can just live with, and essentially the consequence is our snapshot of how the world looks starts to get a little bit stale, particularly if banks go offline for more than an hour or two. One thing that we learned here is that it's important to keep your users in the loop. If you do something like this, the feedback we got from early beta testers was that they'd become so used to the low latency of new transactions showing up in our app, like within a couple minutes of swiping their credit card, that they started to feel uneasy when they saw that things weren't showing up anymore. And it just had to do with this back end scraping thing being repaired. Nothing was wrong. Their finances were safe, and just putting a little note by by the snapshot of the data, indicating that this is good as of yesterday evening, that went a long way. So I think that an important takeaway here is that transparency can lead to a really great user experience, and simply just letting people know that there's something beyond our control, and the last time we were able to retrieve data for your account was at this time, and no action is required on your part, on the part of the user. This really took all of that stress away, and users appreciated that they could rely on us even when these other things were not reliable. This is part of degrading gracefully, making sure that your users don't panic, because sometimes gracefully degrading is something that they will see but not understand. An example of when this wouldn't matter quite so much is if you have something like an online storefront and there is like a recommendation service, and if that service goes down, the consequence is recommended items will not show up, but the users will still be able to go through and deliberately shop for any items that they had in mind. So that's something that can kind of disappear, and it's off the critical workflow, and it doesn't necessarily have to be accompanied by a note saying this service is down and will be back up soon. Particularly in the area of dealing with people's personal finances, we find that communicating a little bit more than you would think leads to being received better by the end user. So let's look at another connection between these system components, particularly when you're dealing with mobile web or mobile app situations. Oftentimes, the client can lose a connection with an API, and a great example of this would be if someone jumps on an airplane, right? So the browser can't see the API anymore. If we apply the same, framework of thinking about this that we did with the other type of broken connection, we need to start by looking at what the browser needs the API for. Well, first, it needs to be able to fetch records. It needs to be able to search for banking institutions, that we can connect to. The user has to be able to recategorize transactions because sometimes the machine learning gets it wrong. And then finally, we have this thing called a budget. It's sort of like a Google Doc where multiple people can collaborate on it at the same time. And we need the ability to create new budgets. These are just the typical things the browser needs the API to be, in the loop for. So now we have to think about, for each of these things, how do we deal with these things in order to get good offline support here? So in order to fetch records, we end up, just because of the number of records we typically have to deal with, other than transactions, we end up being able to just cache what we need in local storage. And the reason we can't cache transactions is because typically we have dozens of like 5 or 6 flavors of records, right? And then with the exception of transactions where we can sometimes have thousands. And so omitting transactions really makes this problem very clear to solve. In terms of searching for banking institutions to connect, we're using the fact that 95% of bank accounts come from 5% of banking institutions. And so we eagerly load that into memory. For mobile web, we use a service worker. For the mobile app, we just populate that using a background task. And then in terms of recategorizing transactions, we're comfortable limiting this functionality when the user is offline. And then the ability to create new budgets, we just use a local storage queue. And again, transparency is important. We had 2 or 3 users that were a little bit confused about why they were able to create a budget on their phone. And then, maybe they were on a flight and they created it while they were in the air. Then they got home and saw that it was not present in the web experience. And the reason was they were still in airplane mode on their phone. So we then made a little UX improvement to be very clear about, what is stored locally on the phone only, and then what has been synchronized with the server. And, that is stuff that they should expect to see through other devices and, through the web UI. The last thing we need to think about is what's the process for going back online. And one key assumption here that is important in terms of making this solution as easy as possible, even if it's not as efficient as possible, and it may do a little work that doesn't always have to be done, but it's sort of it's quick and easy and gets the job done. We assume everything has changed. We assume that nothing may be correct in terms of our last view of the world versus the true, version of the world, which the API owns. So first, we make sure that we persist any records to the API that are queued, for persistence. And this includes those new budgets, right, that the user may have created while offline. In terms of the cache data that we keep in local storage, we basically flush it and refetch everything as soon as we reestablish contact with our API. And a key learning here, and this was an accidental oversight on my part. Make sure that you actually establish the connection with your API and you don't base anything on internet connectivity itself. Particularly when you're going from offline to online, sometimes you will end up being in a kind of trapped Wi-Fi network where you can't really access the internet, but the DNS server is a little bit, hacked so that no matter what page you go to, you get like a Boingo Wi-Fi login screen. Of course, we're not able to like create a secure connection with our API, but what we would find is that we would basically dump all of the cache data too early, and the app would become useless at that moment, right? Because like as soon as we saw like Wi-Fi connection, we aggressively, we tried to persist things, we flushed our cache data, and you want to make sure that you let the app remain in that usable state until you know that you can replace it with an updated version of the world successfully. In this situation, we reauthorize via a channel in order to establish this secure connection with our API. And this will essentially pass the same JSON web token that was last used to make sure that, everything is the same and the password has not changed, since we went offline and came back. And you basically have to assume that this may be a malicious user that like stole a phone and they're trying to like access some financial data here. And so it's always good to make sure you explicitly reauthorize, and that way at least you can track what's going on. So in terms of like where we're trying to go in the future here for more robust solutions, I would love to switch to PouchDB and CouchDB for locally stored data instead of our rudimentary local storage approach. React key value also is quite promising, particularly when dealing with things like CRDTs, which are these data structures that are very easy to resolve conflicts between. They're designed so that conflicts can be resolved easily, even if timestamps are off, and even if multiple things have changed between two different views of a record. It's very easy to merge these together and to get everyone up to date. So that's sort of the more robust solution. But what I'm describing here in total took about a day to implement, and I'll take that and get it out to users, and then kind of go back later and see if something more robust can be put in place that will make things a little bit more efficient and a little more of a solution that we can build more things on. So in summary, when building user experiences for distributed systems, make sure you keep your users in the loop. Transparency goes a long way. Remember to loosely couple, especially with inherently unreliable services. Reliability breeds trust, and people expect apps and APIs to be up almost all the time these days. Remember that it's okay to offer limited offline support, and that users will appreciate, almost any subset of offline experience relative to the total inability to do anything. Don't be afraid to disable a few things. And finally, don't wait for the perfect solution to get finished. Try to build something great today, see how far you can get, put it in front of users. Odds are they'll appreciate it. Thanks a lot, and hope you enjoyed the talk.